So hi guys, me Deepak, and let's see merge sort today. And merge sort basically a dividing algorithm where you first divide the array size by two, and then you recursively call that divide. Then you recursively call it to divide it by two until become single elements, and then you sort and merge them. So it's basically a recursive function. As you can see, you first divide the element to single elements, then you sort them, and then you merge them. So divide, conquer, and combine. So let's see how merge sort actually begins. So you have an array here, a 7. So you divide it into 4 and 3. I'm not going to go into cluster trough of odd or even numbers, but here you can see that you basically calling the function. As you I'm also marking how what functions are called first. As you can see, first there are left functions are being recursively called, and when the condition will fail, as you can see here, when 38 when you are divided into one block, L is equal to R, you cannot call left function more. So then you will call then you will return and call right function, and when the right function is also called, then you will sort and merge them, and then the next then the previous right side will begin with its group of functions like left and right, and then there will be recursive calls until and unless the if statement is filled, and then they'll call back, and then you call right side function, and then you sort them, then you combine them, and then basically you will move back to the function that it all began with, and then you sort and combine them. So it's basically an analog and time complexity algorithm with a bit of lag with space. So it's and big of n space complexity. So let's say a code in C language here. So I'm gonna import a standard library and a standard input output streams, not streams, header files. So I'm gonna import standard input output and standard library, then create the main function and return 0. So guys, we're gonna start by writing the declaring the array function, array data structure, and then we're gonna write 7 elements here. You can write as many as you want. Then we're gonna derive the size of that array by using size of function, because dividing the whole array by dividing, because if you divide an array with its one block, you will get the number of elements in that array. And we are gonna call merge sort, which is gonna use recursive calling, and then calling a merge function at the end. And so it's gonna be void merge sort, and it's gonna have three error L and R. If condition, if L is smaller than R, then it will only we call recursively, because we don't want an infinite loop here, infinite recursion here, sorry. So m is equal to L plus R minus L divided by 2. You can have L plus R by 2, but it won't be the same, if you are sending an array from between, then it will cause difficulties. So for left side, right side, and then merge function, because you see L to M, it will be to left of M, and M plus 1 to R will be to the right side. So it's gonna call recursively, and then when both of the times the if condition fails, then it will call merge function. Then it cannot go any further to divide the elements, and then it will merge them, and then it will call back to the previous function. Its right side will be executed. So okay, so we are in the merge function right now. So we are declaring 3 temporary variables, and then we are gonna create int n1 and n2. N1 is basically m minus l plus 1, and n2 is r minus m. So they're basically gonna be the sizes of the 2 temporary arrays that we are gonna store, because we need because we need to sort the array and then store it into our main ARR array. So let's see. So li and ai plus, you need to be careful. You first need to declare li and ri. And here is an error. You need to do it to j less than n2, not I less than n2. And rj is equal to arr, not a. So even I make mistakes. As you can see, I am declaring now those arrays and their sizes. And there's a semicolon there after rn2. I think you should record yourself when you're writing code. You see mistakes because debugging is a lot of mess. Now let's create the while loop while I is less than n1, and then only we can do the comparison. Then both are in. We would need both the conditions to be true to compare them. So if condition will be if li is less than ri, then we're gonna store the smaller element first, right? So arr is equal to that element which is smaller, and then next statement else statement. So if not, if l is not small, then obviously r will be small. Then we're gonna store r element in the r array, our main array. So basically there's a semicolon that I have skipped, and then we are gonna increment I and k value because we don't want to override those values. It sometimes also creates segmentation faults, so you need to be careful. I plus plus and j k plus plus, that I'm gonna write later. So else ak will be equal to ri. If l is not less, then obviously r will be. And here you will need to increment j value, which I obviously skip because I am a fool. Let's see, increment k plus plus, and then there can be situations where n has more numbers than n, so those elements that are left out will be stored in the array, and those elements will be already sorted. You don't need to be worried about that. What are those arrays sorted? Are those elements sorted in that array? Yes, they will be sorted. They are already sorted because you first started with one elements, and then two elements, and three elements, so they are sorted. And then we're going to call it for j and increment k and j values, and then we will create a print statement, void print array, and also the size of the array. And then we're going to use a for loop here to iterate through the list, through the array, and print out each element. Printf, and you don't need a slash, and you need to have a little space there, modesty space, then because otherwise you're gonna see a lot of jumbled words, jumbled numbers, and you will be like, have I recorded a bug? No, you have not. So I'm gonna call print twice to show that the first how was it previously, and now after sorting how much has it changed. Now let's run it and see if it works. So my code is not gonna work because I have done one mistake. I have not written j++ in the while loop. So if you have not written j++, you will encounter a segmentation fault. So let's see. Yeah, it works. So thanks for watching, guys. I hope you get what I was trying to say.